Hello and welcome. My name is Brian Murphy, and I'm the Technical Marketing Manager for Data Center Services.
During this video, I'll discuss UCS fault codes, explain some of the most commonly experienced fault codes, their proper categorization, and appropriate routing to your IT team. I'll also talk about some of the concepts we apply when responding to UCS faults. The UCS system has the ability to produce 1,309 fault codes. This number probably seems somewhat daunting, but with a little organization and explanation you can make some informed decisions about what actions to take when you receive an alert. There are a lot of questions that go through your mind when you receive a fault or alert from your Cisco UCS. Which codes require immediate action? Which are relatively benign? You must be able to effectively and efficiently determine what action to take in order to have good operational efficiency in your data center. To help with understanding the severity of a fault, you can divide the faults into three categories: reactive, proactive, and predictive. It's important to understand the meaning of these terms. Reactive means that the fault has already occurred. The blade has failed, the processor has overheated, something's broken, and you need to fix it. A proactive fault lets you know that a set threshold has been exceeded and that continuing to exceed that threshold may create issues if the cause of the fault is not fixed soon. The threshold exceeded is non-critical, so you have time to address the problem before any critical functionality adversely affects the system. Predictive means that a critical threshold has been exceeded and immediate action must be applied to prevent further damage or outages. Here's an example of a proactive fault. The fan's performance has fallen below a non-critical threshold and the UCSM sends a warning alert. This gives your IT department an opportunity to replace the fan before it becomes inoperable. Here's an example of a predictive fault. The fan's performance is degraded and the UCSM sends a warning alert. Here's a reactive fault. The fan has stopped working and must be replaced. So you know how fast a fault needs to be remediated. Now you need to figure out who should fix it. Instead of thinking of a server as a box in a rack, consider that a server is defined by the combination of three sets of physical resources: processing resources, or CPU and memory, storage bindings, or connections to external storage, which may contain the boot images and applications, and network interfaces, which are available network connections and network interface cards, host bus adapters, etc. If you think of Cisco Unified Computing in this way, this is exactly how faults should be directed in your UCS data center. The server group takes care of the processing resources, the storage group takes care of storage bindings, and the network group takes care of any network interface issues. As you can see, there are a limited amount of fault codes that are considered critical or major, in other words, service impacting. Many faults are warning or informational rather than actionable. They become part of the log files and provide additional information that is invaluable when troubleshooting complex problems. You may have one critical issue, but it can be correlated with other informational or warning faults to paint a very clear picture of what is wrong. These are some of the most popular diagnostic faults. It is important that your element management system has the proper flapping and dwell time logic for these faults. For example, an interface down fault should be configured to create an incident ticket if it occurred 5 times in 8 hours and has a dwell time of 3 minutes. Otherwise, you'll be notified of an interface down event that may be an administrator bouncing the interface or executing a reboot while troubleshooting. But you'll want to know if the interface bounced many times during a certain period, something that you would not expect to happen during a troubleshooting session. It's also important to add in flapping logic, correlation, and dwell time to properly handle multiple alarms and to combine related alarms as well as making sure they are actionable. For example, if you shut down an interface, you may get layer 3 routing protocol events along with the link state events. Those all should be correlated into one ticket based on the component that failed. Another example, if the fan becomes degraded or inoperable, you may also get environmental alarms such as temperature, and they should be correlated into the same ticket. These are the most often seen environmental faults. Again, these could be the result of a fan failure or other environmental issues that should be correlated into one incident to prevent any disconnect on the part of your IT team. And improved resolution time, because you get more information about an incident and only one engineer is working the incident, instead of an engineer for each alarm. Using intelligent automation is an important aspect of handling UCS alarms efficiently. For example, some of the most common commands the attack engineer executes to gather additional information are show fault detail, and additional show text support commands. This information gathering should be automated and the logs and command output attached to the service request before it is delivered to a TAC engineer. This saves valuable time and greatly improves mean time to resolve. It's important not only to have asynchronous alarms like syslogs, traps, and XML faults. It's also important to pull the device for performance statistics and set appropriate thresholds so you receive events when those thresholds are crossed. In this way, all performance faults are proactive and indicate various severity levels. Based on these severity levels, you can take appropriate action. For example, you want to add in additional resources like disk space or memory if you are continually trending to capacity at a critical state. You could use these events for capacity planning, like at your trends for the disk space or memory utilization, and know that you will need to add disk space or remove log files to free up disk space based on the trend over time. One recommendation: there are over 1,500 performance statistics in UCSM. UCSM retains only 1 hour's worth of data. It's recommended that you capture this data with an EMS platform and store it over a 13-month period so that you have historical data that you can trend, understand, and plan for issues around capacity and performance. Here are a couple of examples of faults created because of misconfiguration. The first fault, server pool is empty, occurs when an IP address pool does not contain any IP addresses. Remove the server pool or add a block of IP addresses. Fault code 334, unassociated service profile, means that the service profile has not been associated with a server or server pool. Check to see if there are faults from attempted associations and take action as necessary to correct the issue, or if the service profile isn't being used, remove it. It's important to make sure that your UCSM is properly configured. Remember, the more alarms, the more traffic, and this traffic could lead to performance degradation. Also, if you receive a lot of these types of faults, you may miss the more important alarms. Today's data centers are under pressure to meet the increasing demand for greater efficiencies and faster access to business applications and information. Lack of visibility in the virtual environment, misconfigurations, and virtual machine movement can cause system downtime and sabotage your business goals, resulting in lost revenue. Cisco Smart Services are targeted to help customers solve their business problems through technology. With our proactive and preemptive monitoring and management services, device intelligence, and intelligent automation is leveraged to help visualize the virtual environment, optimize applications, and produce meaningful alerts, often before the device fails. This saves you valuable resources and increases the efficiency and uptime of your data center. There are a lot of resources on our website that you can use to help you with your unified computing system. Our Cisco support community is a great place to start for technical discussions and problem solving. Our Ask the Experts video blogs and support forums are especially helpful. For more information about Cisco's unified computing system and smart services, please contact your account representative.